Chapter 21 is all about garbage. No, more specifically, solid and then also hazardous waste. It starts with a great case study on e-waste, things from like your cell phones and laptops, etc. It's a great case study, looks at recyclable materials, hazardous waste, and also environmental justice. And we'll talk more about e-waste in class. All right, so generally we can divide up into some different categories. So solid waste can be divided into industrial waste, which is from mines, farms, and industries, and then municipal solid waste, which is all of the stuff that's coming from your homes and your businesses. This is the garbage that you normally think of. And then we have hazardous waste, which we'll deal with in the second part of the chapter. So hazardous waste are things that are poisonous or very, very, very chemically reactive or corrosive or flammable. So figure 21.2 gives you some good examples of things that could be potentially hazardous waste that you might find in your home. All right, so when it comes to hazardous waste, the most developed countries produce about 80 to 90% of it. In the United States, the top producers of hazardous waste are the military, chemical industry, and then the mining industry. And the United States produces about 1/3 of the world's solid waste, but most of that, 98.5%, is industrial. So of that, 3/4 is mining, and then agriculture, and then industry. That sound is my dehumidifier. Apologies. The 1.5% of the waste that's municipal can be broken down. Almost 1/3 of it before recycling is paper and cardboard, and then we got yard waste, food waste, plastics, and metals. The good news here in the U.S. is that per capita municipal solid waste production has decreased. And that's mostly due to an increase in recycling, and also we have lighter weight products, etc. But the total amount of waste being generated has increased. All right, so what do we do about solid waste? So we can talk about waste management versus waste reduction. Waste management is cleanup. So what do we actually do with the waste? Waste reduction is prevention. So how do we actually reduce the amount of waste in the first place? Okay, we have a great flow chart here on page 562, kind of showing where all of the waste can go. And then we have a good summary of priorities in terms of this. So first priority, right, going from prevention to eventually cleanup and management. Okay, so of the 3 R's, right, reduce, reuse, recycle, reduce is by far the most important. So you can think about doing things like redesigning your manufacturing process to produce less waste, make products that are easier to repair and fix, eliminate a lot of the packaging, doing a fee per bag waste collection, because then people will make less waste, and then cradle to grave laws, and also an increase in mass transit could help too. Okay, and then there's some examples of what you can do to actually reduce your amount of solid waste. All right, and then 21.3 gets into reusing and recycling. So really important to think about how we have become a throwaway society. So think of all of the examples in your daily life where you're throwing things away, single packaging of items, single-use items, etc. And so we have some nice case studies here. And what can we do to encourage reusing and recycling? Of course, we can ban throwing out things that could be recycled. We can educate people. Also things like bottle bills, which we have in Massachusetts. So that's when if you get like a bottle of soda and you pay the 5-cent deposit fee, and then you can get that back if you return it. You could also tax plastic bags, which some countries are doing in some cities and towns, and then some are just outright banning them. All right, and then recycling can be divided into 2 major types: primary recycling or closed loop recycling. So that's when you take one thing and make it into the same thing. So aluminum can, recycle it, becomes an aluminum can. Secondary recycling would be something like a whole bunch of plastic bottles are made into fleece. All right, so recyclable waste makes up about 3/4 of that is pre-consumer from the manufacturing processes, and then 1/4 is post-consumer. So that's the stuff that you actually think about recycling. Potentially 60 to up to 75% of municipal solid waste could be recycled, but we actually are much lower than that. There are definitely, on page 566, they go through the environmental and economic advantages to separating recyclables from the trash, rather than using materials recovery facilities or MRFs. And they also talk about composting. You could compost at home, kind of small scale, and then we also have municipal composting. So things like yard waste collection, which is pretty common around here, or food scraps, which is less common. I don't know of any town around us that does food scrap composting on a local level or town level. And we have a couple of good case studies on recycling paper versus plastic. And just beyond recycling, also purchasing products that have been made from recycled materials kind of feeds into that recycling process. And we've got advantages and disadvantages of recycling. So we've got the trade-offs in figure 2112, some info on bioplastics, and also information on what the government can do, which is always important. So it gives you some ideas beyond just ban things, what can the government actually do to encourage recycling? All right, and then 21.4 is basically saying like, all right, so all of this municipal solid waste, this trash or garbage that we generate, we can do one of two things with it. We can burn it or we can bury it. So we can see up here, figure 2113 kind of shows what happens in a waste to energy incinerator, how they work. So that's when you're burning trash to generate usable electricity. We have a couple of these around us. They're only economically feasible in densely populated areas, but there's one in North Andover, there's one in Saugus, so they're close by. We also have some pros and cons of waste to energy incineration on that same page. The other thing, which is what most of our trash here in the United States ends up in a sanitary landfill. This is different from an open dump. We don't have any open dumps in our country, luckily. We used to, but we don't now. So please pay attention in figure 2115 to all of the different components of a sanitary landfill. Notice that there are linings, there's leachate collection. Leachate's basically, picture all the water that flows through all that trash and it kind of picks up lots of nasty stuff. That's your leachate. There's methane collection, a whole bunch of stuff. And then we've got the pros and cons of those sanitary landfills too. Okay, so again, sanitary landfill, not an open dump. All right, and then finally, hazardous waste. What do we do with all of this? So there's an idea of integrated management of hazardous waste, which is basically saying like, hey, why don't one company produces a particular waste that can then be used and sold or traded to another company that can use that waste in the manufacturing of something they're making, etc. So kind of recycling and reusing this. About 1/3 of hazardous waste in Europe is managed this way, but about 1/10 in the United States. Figure 2117 kind of shows us our best, good, and okay things to do, kind of an overall, what can we do with hazardous waste? All right, so one thing we can do is detoxify it, so make it less harmful. There are physical methods like filtering it through charcoal or distilling it. There are chemical reactions, nanomagnets that can be used. Biological detoxification could be bioremediation, using things like bacteria and enzymes that will naturally break down the wastes, or phytoremediation. There are a lot of plants which are highlighted in figure 2118 that can absorb wastes and kind of process them and make them less toxic. Biological detoxification is awesome. It can work really well and be much less expensive, but it takes longer than physical or chemical means. Some hazardous waste can be incinerated. You can think of some good things and bad things about that. And then the book also talks about a plasma arc torch. I don't know that you'll ever see that on the AP exam, but I mention it because it's in here and they do have trade-offs there. What ends up, though, is that a lot of our hazardous waste we end up just storing. So it's kind of our least desirable, but most often used solution to store it, right? Because we've produced it, what do we do with it? So it could be in a deep well disposal, which we can see in figure 2120, gives you some advantages and disadvantages of that, or surface impoundments, which is basically like a big pond of waste that the water evaporates and kind of concentrates all of the waste. So each of those have pros and cons as well. Pages are stuck. There we go. This case study here, starting on page 578, great overview of what we do in the United States to deal with hazardous waste. So we have RCRA, or the Resource Conservation and Recovery Act, which is the cradle to grave kind of law where companies are responsible for every kind of step of the production of any waste. but this only covers about less than 5% of hazardous waste. The most recent data I've seen is about 4%. So it's something, but it's not covering a lot of it. CERCLA, which is the Comprehensive Environmental Response Compensation and Liability Act, or Superfund. So we've already started doing some research on CERCLA and Superfund, right? That's where we are dealing with the cleanup of hazardous waste sites. It is an underfunded law at this point. And a part of that is the toxic release inventory, which is where you can look up and see like, hey, where the companies basically have to report how many toxins are being released into the environment. And there's also some information here about brownfields, which are abandoned commercial or industrial sites that usually, a lot of times the soil has a lot of hazardous material in it or toxins, and these can be cleaned up and redeveloped. So the Wynn Casino site in Everett is on a brownfield. And so one of the first things they had to do before they could start construction or anything was basically remove the contaminated soil, and then they start to actually make the land usable again. Right, and then the last section just deals with how can we become more sustainable, low-waste society. Gives you a definition of environmental justice. Basically, this is the idea of not in my backyard, right? Bad stuff is like hazardous waste sites, for example, are disproportionately located in minority communities. And then studies have also found that cleanup happens a lot faster in white communities, and cleanup is more effective and more complete. Then we have a couple of international treaties which are important to know. The Basel Convention basically bans the shipment of hazardous waste from more developed countries to less developed countries. So things like our e-waste that we ship to China, that's against the Basel Convention. The US and Haiti signed the Basel Convention but have not actually ratified it. Another one is the Stockholm Convention. This regulates, and then eventually they revisited it and added a little more to actually ban some persistent organic pollutants, things like DDT, PCBs, dioxins. This is another one not ratified by the United States. So like we can't use DDT here in the United States for mosquito control, but they can still use it in areas where malaria is present, for example. Right? And then the last part of the chapter talks about biomimicry and how we could use kind of mimic nature, right? So like they give this example here on page 582 of in nature we have food webs, so here we could do a waste web, if you will, and how different things could be used. So we see one example like the electric power plant has waste heat, which is then used to heat area homes, which we talked about in our energy chapter. So that is chapter 21 in 13 minutes.